Well, hi, and welcome to my shop on this snowy December 10th. And I think what I'm going to do with the radio today is do an alignment on it. What I'm interested in finding out is the alignment way off? Is this one of the reasons why this radio isn't performing so well? Or maybe this radio is actually performing really well, it's just the circumstances here in my shop don't allow the poor radio to really reveal its capabilities. But we'll go through the alignment anyway. We'll do it using instruments, and we should find out, it should become apparent if the alignment was really an issue with this radio. So to that goal, I have set up my signal generator here. It's pumping out 455 kilohertz, which is the proper frequency for the IF in this radio. I'm prepared a connection onto the grid of the IF amplifier tube. That's the 6SK7. It's hanging out here. It's this capacitor, so this goes to the grid of that tube. I've installed a short on the antenna as required in the alignment instructions. It's a 0.1 microfarad capacitor right across the antenna. It may not look like it here, but it is. It's actually shorting the antenna to the chassis. And lastly, that's it. So I have my output of the signal generator. I clip it there, and we're in business, injecting 455 into the grid of the IF. That 455 grid of the IF amplifier tube. That 455 will then pass through the second IF can. What comes out will go in the detector, get rectified. The rectified voltage is going to show up on this meter, which we commonly call the AVC voltage. That is the plan. I think I've got everything set up. This guy's on the 50 volt scale. Let's put him on the 15 volt scale here. The signal here, this is modulated. It doesn't really have to be modulated. We'll worry about that later. It's a moderate strength. We're good. Okay. Let's flip them on. So again, even though I have these dim bulbs in the circuit, the current draw on this radio is fairly low. So the voltage being lost on that little light bulb over there isn't all that much. And you can see what's reaching the radio here. About 110 volts. Okay, in order to do this, I'm going to run this at full supply voltage. So let's just hear it. So I have the short on the antenna, even though I've got this mile of wire hanging off of it. The short has really quieted it right down. Perfect. Turn this back down. You really need to clean this volume control to get rid of a few funny things there. Okay, we're all set. Inject the signal here. Woo la wee! Wasn't that exciting? So, yeah, I expected a little more response than that. Just move it over this way. Okay, that's to give me a little better standing space here. So let's try tuning the signal generator now. Unfortunately, my frequency counter's gone berserk. Let's just see if there's something around here. No. A little more juice. Something funny going on here. Something funny's going on. Ground. Grid. Maybe I made the wrong connection here. Grid. Let's give it a little more juice. Oh, I think it's way off. Oh my gosh, way off. Can that be the case? Wow. Okay, so I get the impression it's way up, but unfortunately you can see my frequency counter there has gone berserk. So it does this from time to time. Yes, it needs a repair. So we're just going to leave it like that right now. I don't know for sure what frequency this is tuned to until that stops. Probably stop in a couple minutes. So first I'm going to give it full power here. So now it's running at 124 volt supply. That's a little higher than what it should be in the house. The gain capacitor should be fully meshed during this process. There we are. Hey, oh, good show. It just stopped. Look at that. Can you see it? Can you see what that says? 400 hertz. 400 instead of 455. Oh my gosh, I've never had one this bad. Is that for real? I don't even believe it. Wow. Never had one this bad. In fact, in my experience in doing hundreds of radios, I've only found a couple where the IF had been worked by somebody without instruments. That's the impression I get. Either they don't realize what they're doing at all, they just start turning those screws, or they're tuning against a received radio signal. That can lead you to this kind of thing. This could also be like tuning the IF way off is a way to compensate for the pointer not being accurate on the dial, but it's a poor way of doing it, but it's a cheaty way of doing it. But it would happen by accident if you intended to tune up the radio IF just by tuning in a radio station and peaking it. So because if the pointer's in the wrong place on the string, you're going to force the rest of the radio to match that wrongness, and that may be what's happened here. Oh my gosh, I still don't believe it. Let's see if we can prove it. So what I'll do is I'm going to adjust the capacitors here. Let me just flip my camera. Whoa, what are you looking at? Keep that in view. Let me turn this. Ooh, it is hot. There. Turn that out. Turn this guy around. This is there we go. Okay, so we'll go in. Oh, we need to see the meter. We need to see the IF meter, or the. We need to see the. Okay, what I'll have to do. I think I want to tune the signal generator back and forth and watch this meter because it's barely coming up. We're on the 1.5 volt scale, so there's a tiny voltage here. This could be another indication the IF is just way out of whack here. This can may be tuned to 400, the other one may be tuned to 455. So, but let me just watch the ABC work here. I'm going to reach across, try not to stick my head in the way. Wow. There's barely any movement in that meter. You might not have even seen it on camera. Barely any movement. Maybe another artifact of badly aligned IF. Okay, I think we're all set. Everything says 455 is where we should be. So let me back this up a little bit and get the whole show on screen here. Okay, I'm liable to step right in front of that meter. A little tough on the camera angles here. Let me fix that. I got a plan. Let me fix that. Okay, there's a good meter view. And here, let me just tune that signal generator again while you're getting a close look at it. That's the ABC voltage variation. I'm going to jump up the input level here. Maybe that'll make a big difference. Made a difference on my ears. So yeah, I am putting in a fairly low signal. That's okay. we can't know for sure, I guess, just how well this is working. So, but you can keep your eye on that meter now in the top left corner. And we're going to try to move this thing up to 455. I wonder, well, we'll find out where the other one is. We'll start with this one, 455. Again, I've got a bit of a camera angle headache here. And I got a lighting headache. Okay, let's try that. Good. Now I'm using a steel or a metal screwdriver for this. Now, most of the time using a metal, not most of the time, some of the time using a metal tool is a big mistake. If there's slugs inside these cans, you're trying to move cores, then if you get at them with a metal screwdriver, it's probably not the best thing. You put the metal screwdriver in, you throw the resonance off. But you can, I find, you can use a metal screwdriver on capacitors. These are capacitors up here. And more importantly, the stiffness of the screwdriver shaft is critical in making the fine adjustment. Now, this is a pretty stiff tool. This one would work okay too, but let me show you one that wouldn't work very well. So this long thing. So it has a flat edge. You can actually use it. I can put it in there, but when I engage with the screw and I begin to turn, a fair bit of that turning moment or pressure will just be absorbed in a twist here. So what the screw feels is much less than what you're applying up at the top. And when the screw finally breaks free, boom, it'll jump. It'll jump, 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 jump. You'll never ever get it nailed down, which is why I tend to use the metal tools to do this. So enough of an explanation. Let's do it. Okay, eyes upon the meter. Right, we're in. Okay, we're in. Watching the meter now. Wait a minute, I gotta move this. So we want this to go up to 455. So I'll start moving it that way. So I can still just barely hear it. Now I'll turn this to strengthen it. What's the problem here? I must be on the wrong IF. I'm on the wrong IF can. It must be this one. Okay, here we go. Yeah. So 406. Okay, let's find it. Now what's happening is it's getting weak very fast because the other half of this transformer is apparently tuned to 400. Let's move it up too. Okay. Okay, move right past, a little bit past. We'll turn this up. Gotta be careful now. We get three things going here. Okay, I can still hear it. Turning. When a radio is this far out of whack, you need to follow the instructions verbatim. You need to inject the signal into the grid. You can't cheat by just blasting it from the antenna or something like that I do quite often. Still hear it? Barely. Okay, so I get these two coils out of alignment too much, the signal won't go through, won't hear it. There we are. Back a little bit. Let me turn this up. That might help too. Okay, we're getting close to 455 now. 440, 450. Okay. As you get these things closer to where they're supposed to be, that's what they're designed for. They probably work better at 455 than 400 is way out. Okay, so we're now set. It says 454, but it's really 455 or so. Okay. Now we'll try to peak this guy right up. I paid no attention to the ABC here, but I will now. So little variation. Sounds okay. Small variation, there may be a resistor that's gone way high or something like that. Maybe I'm feeding a tiny signal into the IF and don't realize it. So there we are, 455 on that can. Now I've got to move the injection point in the radio to grid of the 6 SA7. Grid of the 6 SA7. So if you just bear with me here, I'll figure that out quickly. The grid of the 6 SA7 is pin number 5. Pin number, wait a minute. No. The grid I'm after, pin number 8. This is to feed an IF signal in. No, then it would be pin number 5. So 5 is, there's two grids on this tube. 5 is the grid that's connected. 5 is the grid that's connected to the oscillator. Why don't we go right on that one? So we need to get at the 6 SA7, 12 SA7, 12 SA7, which is this tube here. And we want to get on pin number 6. 1, 2, 3, 4, 5, 6. Pin 6 is this black wire, and pin 6, this black wire connects to this coil right here, so we can go there. So I'm going to pull out the, and I'm going to turn it off. I'm just too chicken. Pull this out. Clip it down here. My hands are very sweaty this morning. I don't know why, but they're very, very, very sweaty. I have low impedance hands for sure. Low resistance hands. So, that should do it. So this should now, so we're going to find out, without changing the signal injection level, we've simply gone from the grid of the tube while we were listening and went the other side of the transformer, grid of a tube. No, there's too much in there to make any judgments. Did that make any sense to anybody? Okay, made sense to me. Okay, so long as the pilot understands, I guess we're okay. So let's switch it back on. That would help. See what comes out, if anything. So we know the second transformer is 455 now, so any degradation of the 455 signal has got to be coming from the other transformer. Anybody hear anything? And now, because we've got one IF tuned here, how can I show this? One IF tuned here, and the other IF, instead of being lined up with it, is over here. So at this moment, it's not likely much is going to come out of this radio until I get the first one in line with the second one. But if I crank it up, we'd probably hear something. Crank up the input. Let's give it a little more juice here. There it is. Perfect. So now we'll be able to tune the other IF transformer, and we should see, I would guess, a huge increase in the signal level here. Okay, other can. This might be crazy. Down, up, oh yeah, here it comes. First radio I've ever had way off like this. Oh man. So there's a good chance these two cans were both tuned to 400, but there's a good chance they weren't. And that would be a pretty good explanation for why the reception was so poor on a radio with an extra. No, this one doesn't have the extra front end tube. There we go. Okay, so I'm going to tune the signal generator through a couple times and just listen to whether it's a nice smooth rise and fall or whether it's got a couple of bumps in it or what. I'll just do this by hand. There we go. Sounded pretty good to me. Don't know what that heterodyne tone is coming through though. So listen to it this time. Just listen, pay attention to the hiss relative to the tone. Getting maximum hiss around there. So, you know, typically in a radio, when a signal's not present, there's no AVC voltage, the gain of the front end goes up and the hiss level goes up, the noise level goes up. So you expect as you tune into a station, the AVC voltage drives down the noise because it's driving down the sensitivity of the radio. This one's going the other way. They tune through the signal. Now this is an IF signal only, but I don't think it should matter. The hiss comes with it. Exactly what that means, I don't know. And the AVC action here is still pretty minimal. That's good enough for now, I think, on the IF. It's good enough. Now, if the IF is out, everything could be out, I guess. The other adjustments are right up on the capacitor to do the other RF adjustments. We should take a poke. Somebody may have just gone at all these to see what would happen. Switch off the radio for now. I want to remove everything from underneath. Don't think we want to maintain the short on the antenna. Really? I don't know. Cleverly put this in here. There. This can come out of here. And we can lay the radio down. Or set it down. Next two adjustments are these two screws here. Let's just move our AVC over there. Good, I think that's good. Okay, power on again. See what happens to that AVC meter. Oh, something not right. Something not right. What's the problem here? Oh, the meter lead here. The meter lead here is connected still to the volume control, but I took the ground away, the ground from the meter away, and I didn't reestablish it. That's where that hum has come from. I'm going to put this back on, but we don't want to just, you know, I better put it right on the B- point. I got to get up under there again. This great big bear. Clip, don't like that. Let's try another clip. Get up under there somewhat safely again. Okay. B- is right here. Like that. Okay, I think we'll be okay this time. I don't know. Let's see. Will we be okay? Yeah. Getting a pretty high AVC over here. Is that because we tuned up the IF? I think it is. Okay, 15 volts now, full scale. Well, it's better. I think it's better. Okay, let's continue on with the alignment process here. The next step, I'm just going to take a look at the, is you want a 200 picofarad capacitor through which we're feeding a 1460 kilocycle signal into the antenna. So we want to isolate the signal generator with a very small capacitor. Okay, particularly have one that small handy with a clip on it. 200 pico. Yikes. That's a point. That's 200 picofarads. That's exactly 200 picofarads right there. The resistor. So the idea is to feed into the antenna. This is kind of a crazy situation. The antenna is a mile long here. I don't know. This really makes a lot of sense. Feed in on the end of a long piece of wire. Kind of think it would go the other way. So we'll take the negative of the signal generator and do the same thing. We'll put it on the B minus here. I'm a scaredy cat. I can hide that under there. And then we're going to feed the signal in. We'll feed in we'll feed in the IF and see what happens. So the radio's gone quiet right away, and part of that could be just hooking up this lead without the capacitor they required. Wait a minute. Here. No, same thing. It's going quiet because the output impedance of this signal generator is very, very low. So I'm essentially putting a short on the antenna. A short with a powerful signal in it. If I just dial it up to somewhere around 600. Okay, let's do that. Around 600. Put a moderate signal strength into it. Well, not coming through. Okay, so this is quite a strong signal now. Oh, there it is, way down here. So the challenge with this radio is there's no dial. The dial's in the cabinet. But what I do see are some markings on here, these black markings. Almost certainly they're there for a reason. Almost certainly they're there during the manufacturing stages when they want to tune this radio as it comes out. Why so many spots? Maybe there's a hint in the alignment instructions. Let me just take a peek here. You know, it says it does not actually. Oh yeah, radio dial setting 1640. Well, how do I know it's on, or 1460? How do I know it's on 1460? Huh. Okay, it doesn't say anything about marks on the front or anything. If I put this back in the cabinet, you cannot access these. So if I can't get the dial-up plate in front of it. Well, let's move the dial back and forth and see if we can identify what any of these marks are. Like these two outside ones might be the limit. Okay, so right on the one here. Right past, way past the other. So often these radios, one of the first alignment steps is to align the pointer on the string. And so they tell you to do something like mesh fully the capacitor. And then you look for a mark. Sometimes it's on the glass plate. Other times it's right on here. A mark to help you align the pointer. So it's aligned right on this first mark. So let's assume the first mark is the pointer mark. The next mark would probably be, and I'm looking at the alignment instructions, 600. That's probably 600. And then 1460. So 1600 would be here. This could be 1460. Or I could be totally wrong about the whole thing. So why don't we dial up 1460 on the signal generator, see if it's anywhere near here. I don't know, why don't we? Let's do that. 1640. No, 1460. Trying to get myself all confused. Wow. A weak reception at 1338. Now what's possibly happened here? The IF way out of alignment makes the pointer incorrect. Somebody may have pushed the pointer on the string to make it align. I don't think so though, because we did this test and it lined up with this first line. So I think what we're seeing is the effect. Now wait a minute, the alignment is correct now on the IF, so the pointer should be correct on the IF. So if this is 1460, that should say 1460 up there. Plus the local oscillator is so far out. Okay, local oscillator. So let's do that next. That makes perfect sense. We're going to continue to assume this is 1460 and see if we can't drive this radio by adjusting the trimmer so that 1460 is real. You can hardly hear it. Now there's a chance I'm making a big mistake here and I'm tuning into an image. And maybe when we're done we'll do some image testing on here. How do I know this is not the image? Don't really know. Well, if it was, it would be like a million out. It's not. It's only a couple 100,000. So one of these two screws here is the oscillator. Let's find out which one. So I'm just interfering with the capacitor, and it sounds like a tuning thing to me happening here. And that sounds like antenna. So the smaller capacitor must be the local oscillator, so I have determined. Capacitor seems to be driven in fairly tight. So we want to go to 1460 from here. So I'm going to go up a little bit. I can still hear it. And turn this screw and see if I can make it louder now. My metal screwdriver is affecting this a little bit. Good. So I loosened it off because that's the only way this screw is going, and it came back. Excellent. So I think I can drive this all the way to 460 because this is cranked down. You couldn't get this any tighter, I don't think. So I'm just going ahead and turning it quite a distance here. I see the radio's getting louder as I do this. I'm beginning to line everything up into the same spot. because I think when we started here, everything was a little out of here and there. Okay, so let me turn this up now to get the signal back and max it. Oh, I almost made it to 1460 already. Excellent. Wow. Okay, so I gotta look at the ABC meter now. Get fooled by the interfering signal. Let me take over the radio here. Okay, so it's at 1469. I really want this at 1460. Oh, don't jump out on me now. Hang on there. My metal screwdriver is interfering a bit, but you know, the stiffness is still worth it. The stiffness of the screwdriver shaft. Bring it up to 1460. That'd be 1460. I can smell some heat in here. Shouldn't be any heat in that. That's that odor of oldness being heated up. That's what it smells like. So we got 1460. Good. That's good. Now we'll go to what I imagine is 600. This line I'm pointing at. The second line I imagine is 600. Because that would be 530 at the bottom. 600. Let me just take a peek at the scale. Huh. I don't know. This might be 600. Well, let's see how easy it is to tune the radio to 600 here. So we'll change the signal generator down to 600. So that's the IF coming through. Wow, nice and strong signal now. ABC jumping around. Fantastic. So there is only one oscillator adjustment. So with it adjusted for what I think is correct here, this does not come out. This comes out to be 550. This is quite possible. When I looked at the dial, 550 is written on the dial, and I'm sure the dial can go farther this way. So maybe this is 600. Let's tune it up there. See if we get 600 here. There it is. Right on the money. Let's peek that meter. Right there. 600. Excellent. I think that's the case. Probably this is probably where you're supposed to. Does it ever talk about a middle frequency? No, it does not. So it's at 1460. You do the broadcast oscillator and the antenna. At 600, where we are now, you just make a measurement. You don't actually make any adjustments. So go back up to 1460. And go other side. Okay, so now that's interesting. That so we're somewhere around, say, 1200. Down here we have the signal generator running at 600, but we're hearing 600 up here. 1200. I'm not sure what to make of that, frankly. I was going to say that's the image signal, but I'd have to think about it a lot more to be sure of it. I want to be sure of it. Carrying on with what we're doing. 1460. We'll explore this image thing separately. I'm really curious about it. 1460. Okay. Now we want to pick up the antenna capacitor. We're doing this with this arrangement here with my signal generator. I'll do it again when we just have an antenna hooked up. We'll do it with a signal generator. See how far out this one is, if it is at all. Okay, watching the meter. That's tightening, tightening, tightening. It's about a peak there. It's pretty tight now. Okay, here we are. Aligned, I wouldn't even say roughly. It's pretty good alignment done. So let's hook this guy up. Let's play him on his wire antenna here. Okay, don't get too excited now, Jim. You make a mistake. Okay. Off we come. A carefully placed antenna. There it is. That worked really well last time. Let's see where we get. Just go down through the band. I normally don't receive any signals up here with the radio like this. There's a French station right in this area though. I locked that screw in so tight. Oops. I can hear the peak better than I can see it on the meter. This is very good performance. Hearing this station this well, that's really good performance. I shouldn't hear anything else now until we get to, well, we might hear some stuff. Let's see. And find out what frequency we're listening to. .640. 640 is a relatively strong signal here. Many radios produce it much better. 640. Signal generator. Yeah, it is still hooked up. Unhook it, man. So this is 590. This is the strongest station. This is the one station this radio could pick up right from the start. Let's fool with the antenna a little bit. Okay, didn't really do much of anything. But we will connect it to an outdoor antenna here. Just going to do this kind of clumsily at first. Now, my outdoor antenna is not actually turned on here. Can I even get it in there? Oh, that's a lot better. Okay, so I'm going to go switch on my outdoor antenna and then we're going to hook up to it properly. I shall return brief in a moment. Okay, we're switched in here. Let me get the proper cord. Now, potentially hook this to the net B minus, but I'm not sure it'll help. Leave it off. Okay, so this is my outdoor house antenna now.
It's really not great. It's a huge day here, so we're going to be at our very best. So you know what? I don't think we care.
I believe it. Well, Brian, thanks for letting me.
That's attaching the antenna coax cable ground. I adjusted that capacitor on this signal. Hey, more stuff. It was too late. Yay, yay. Better all the time. Another thing somebody may have done is they may have, I don't know how they would have done this, penciled particular stations onto here that they know they can pick up here. How they would have done that, I don't know. But, okay, let's adjust that side screw. This is the antenna tuning. Open up is better. So we're going to close it a little bit here. This is not making a big difference anyway. There we have it. Excellent. Excellent. So all that's left now, believe me, in another location in my house, this radio would sound a lot better. My shop is like the worst place to play radios. That's unfortunately the situation. So I'm pretty happy with that result. I'm not going to bother doing any more capacitors. It's just not worth doing because it's working great and it's largely original. It's kind of neat. All that's really left for me to do now is to fix up the cabinet. The cabinet. Let's take a look at it. And I'm not really a cabinet guy. So you say, well, this cabinet at a glance is horrible, right? It's just horrible. Where does your eye go when you look at this cabinet? Mine goes right to this stuff here. I can't help it. I gotta look at all this crap here and all this stuff. That's not what your eye is supposed to do. Secondly, my eye goes into what's going on here? What's that speck? You know, there's a white drop of paint. Of course, all good radios have some paint on them. Yeah, definitely paint specked here and there. And you know, this is really dirty and stuff. So, what about the sides of it? So again, it's not particularly damaged or anything. It's just kind of dirty. The top is terrible, dirt. So I'm going to clean this thing up. We'll see what we end up with. I'm really hopeful it's going to really pop. I'm hoping this the red panel here pops out nice and everything. That's what's left for me to do for the rest of the day while the snow falls. Yes, we're getting 1 to 2 feet of snow today. I don't think I mentioned that. So, thanks so much for watching. And we'll see what this looks like when it's all back together. I think that's what's happening next. We'll see you.